Yeah, so for anybody wondering, I've been updating the homework, as much as I could recently, especially like during the wind times and things like that. I was able to get it done. So your grade should be pretty current. I have them marked missing if it's chapter 6 or chapter 7. So those two chapters definitely should be in by now, since it was a couple weeks ago. Other than that, chapter 8, I'm obviously not going to be marking missing or anything like that. Do your best to try to get the homework done. I know we're kind of flying through these end sections, so I get that it's not like you're going to just flat out have that much time to just work on homework constantly while you're also studying for the AP test. So know that I'm going to be pretty flexible on the Unit 8 homework. I don't want you guys taking away time. If you're trying to get ready for the whole AP test, I don't want you taking away time from that just to get your homework done or anything like that. So our Unit 8 homework, I'll just kind of constantly be checking it. And, I'll just probably talk to you individually if things aren't turned in, and I'll kind of check with you to make sure things are going all right. There's not going to be a set deadline for it. Let's see. So we have 3 sections left. And we have 1, 2, 3, 4, 5 days to do it. Shouldn't be a problem. We most definitely are going to finish 8.5 today, which is great, because 8.6 and 8.7 sometimes can be really slow to draw, to set up. Honestly, if I can get done early and have any kind of time to just go over details of what you should bring to the test, things like that, I'd love to be able to do that Thursday, Friday if I can. Okay, so 8.5 is going to be on volumes of cross sections. Honestly, I'm not expecting any of you to even know what that means just by that name. What's going to happen is there's going to be 2 kinds of volume questions that you're going to run into on the AP test. And on the free response section, every single year there has been a single, I shouldn't say a single, at least one. I can't remember the last time I've seen 2, but there generally is one volume question from an AP free response question. And if you know how to set them up, they're not that difficult. I do know that some of you guys have trouble visualizing things in your head, and that's usually the biggest issue with students for these sections, is just even trying to figure out what it looks like, what they're talking about. So I'll do my best to try to draw this. Honestly, it's not great at trying to draw it. So let's say we have some sort of a parabola like that. And we have an enclosed area created by this parabola and the x-axis. For this style problem, you're going to be told that this is the base of a 3-dimensional object whose cross sections are something. Now, I noticed in these notes that there are 6 shapes listed. Is that correct? Did I remember that right? I think it has squares, rectangles, semicircles, right triangles, and then I think a right triangle with a hypotenuse as the base and an equilateral triangle. As far as everything I've ever heard, those last 2 shapes are not on the AP test. Now, I suppose it's always possible that can happen, but from everything I've been told in previous years, it's one of 3 shapes. A rectangular shape, which includes a square, a semicircle, or a right triangle with a leg as the base. Isosceles right triangle, which I isosceles. Now, like I said, they don't actually ever tell us what's on the test, so it's possible they could put in a different shape. They traditionally will pick these three shapes as the cross sections because they are far easier to set up and far quicker. Like, say, the equilateral triangle one is only easy if you know the formula for an equilateral triangle. And most people don't. Most people usually kind of figure it out rather than just memorize it. So they usually try to keep it to a shape that's pretty straightforward. Okay, so I'll try to draw this. Oh, this is better than I thought so far. Okay, so pretend that that is the base. So that's my 3D perspective of it laying flat. The three-dimensional shape created from it, you'll have to be told, and it'll say something like, let's just do a square because that's probably the easiest. It'll say the cross section is a square that is perpendicular to the x-axis or y-axis or something. So perpendicular to the x-axis would mean the base of the square would look like that, and then the square would come up out of it. And then this entire shape would be made up of squares whose size of the square is determined by the length of the base, right? So like on this shape, this would be the biggest square right in the center. Every square towards the outside would be very small. Ooh, that was a bad one. And I know from your perspective, trying to draw these in your notes is rough. I've always found these super fun to draw, but they can be difficult to visualize, right? Like, if you turn to the 4th page of your notes, I believe it's the 4th page, there should be some that are already drawn. Is that right? Yeah. So obviously the computer generated ones are going to be, far superior to my drawing skills. I didn't even think of it. I will have to take them out for Monday's class. In previous years, students have made models of these for their project at the end of the year so that I could use them as teaching aids, and I totally forgot about them because we haven't done the projects for so long. So I'll take some out for Monday to show you. But that's kind of how these three-dimensional shapes are going to be created. You're going to be asked to find the volume of them. Now, do you remember, what was the last time we met? Tuesday? Yeah. Which I know makes this extremely hard to have cohesive thoughts when you keep getting interrupted to stuff. On Tuesday, we integrated the line length, and then that found the area of this shape. This is going to be the same process. We're going to integrate the area of this cross section, and then that's going to find us the volume. So the whole point of integrating is that it means you add up a bunch of them along the way. So if we integrate the area of this square, not a number area, but a formula that represents the area, we're going to be able to come up with the volume created from it. And that's going to be the process. So I figured I would try to do my best to at least draw one of these for you before we try to do a problem so that you even know what it's talking about. So this is going to be the bottom of a shape. and it's going to be coming out of the paper at you. Okay. I think the first problem was on the next page, right? Yeah. Okay, so we'll start by doing this one together. Find the volume of the solid whose base is bounded by the function y equals square root of x, x equals 4 on the x-axis. Sometimes that's given for you as a drawing. Sometimes they'll just give you the equations. Now this one obviously has the drawing, and it's an enclosed area made up of that half parabola, straight line up and down, and then the x-axis is like y equals 0. Each cross-section is going to be a square taken perpendicular to the x-axis. So if I were to draw a single cross-section, that's probably going to be the best option for you guys. I'm going to draw a single cross-section. And here's how I do it. I don't care how you guys do it. I usually try to draw it like 3D coming out of the paper, so it's like my brain can kind of figure. Well, that was a bad one. Then my brain can kind of figure it out. There's not really going to be a good option for this. I mean, like you're trying to visualize a three-dimensional object from a two-dimensional drawing. But the reason I want to draw a single cross-section is because it's going to be easier for you to come up with the information that tells us the size of that square. So our goal is we are going to integrate the area of the square. That's what we're trying to figure out. I know it's going to be dx because it's vertical. So I think you guys probably had enough practice at this on Tuesday. Things set up vertically will be using x's. Things set up horizontally will be using y's. Okay, how do I find the length of this line? That's what we did Tuesday. Should I call on people, or is that mean? Should just not call on Casey is what you're saying? I see. Is this, I don't know how to phrase this question. Is this really difficult for you, or is this, you're just not wanting to like volunteer? Is it both? In between?
Do you find the length of a line, is it like top minus bottom or right minus left?
Yep, correct. If you want to find out how long a line is, you're going to take the top information minus the bottom information. And I say information because it's not going to be a single number usually. It can be. It's usually going to be an equation. Like this top point is obviously changing constantly on this curve. But the good thing is we know that the top point will always have a height of square root of x. The bottom point will actually always have the exact same height. What's the height of the bottom point? 0, because it's y equals 0. So we've got y equals square root of x, y equals 0. So I'm going to subtract these two to find the length. Okay? How do we find the area of a square? You got to go with a generic formula, right? So it's this.
How do you know that top is square root of x?
So we're told this curve is f of x, or y equals whatever. That curve is created by always taking the square root of the x value at that spot. I mean, I only know it because it's over there.
Oh.
It's not like I looked and knew that curve was that. We were told the equation.
Okay.
So you'll definitely have to be given that. It's not something you come up with. So square is side squared. The side length is what we just figured out, which is going to be square root of x minus 0. And obviously you don't have to write minus 0. I'm just going to do that to get you in the habit of it. Like learning to get in the habit of writing top minus bottom information constantly is going to help you out a lot in 8.6 and 8.7. It feels more confusing when we get to that section. And go ahead and ask questions if you're not even sure why I'm writing certain information. Yeah.
Why do we square it?
Just because the area of a square is the side length squared.
Oh, okay.
Edge squared, whatever you want to call it, yeah.
Thank you.
Yep. And then you generally have to do the actual integration. This one, oh shoot, I forgot to write the numbers. I'm getting too ahead of myself. What numbers do I put on there? I think I heard somebody say it, but they weren't confident, so they whispered it.
0 to 2,
0 to 2? How come?
because we're integrating the lengths around an x-axis.
Very true. How should I say it? Why should it be 0 to 4? I don't know if did you pick 2 because that's where I drew my line, or did you do square root of 4? I don't know.
I just apologize.
You were just taking a guess? Well, it sounded very confident. I like it. It's going to be 0 to 4 because the first square I would draw would be at x equals 0. The last square that I would draw would be at x equals 4. So that base colored in shape is kind of what determines where you would draw them. Square root of x squared is actually just x. Like this one was picked to have easy info. Did you get it figured out?
Yeah, I got it.
Okay. I was just trying to save space. Do you guys want me to explain why I put an x?
Yeah.
Okay. So square root of x minus 0 is just square root of x. And then if I square root of x, they cancel each other out and become an x. So I was kind of just trying to save space because of that, but you definitely don't need to. So then I integrate x with the power rule. And then I'm going to plug in 4. And then plug in 0, which is 0. Oh, come on. I almost wrote units square on accident. How 0 to 5, how is that feeling? How confident are we on that type of question? You guys are very silent today, and I don't know if I've killed you off or not. So it's all over the place. All right. That's all right. That means it's not. For most students, this is considered difficult. I mean, like, you're involving a lot of different math processes. I've just always liked these because I just like drawing them and picturing them. But I know I'm weird, so.
Yeah, but you didn't do one.
Should we try to?
She's saying roughly.
Like, you guys are okay with one? You're giving me very weird vibes today. Is it because this is our only second day of meeting this week?
Yeah.
Okay. I'm really glad that we have all next week right before the AP test. Although, I suppose some of you, I think AP test starts that week, right? Do some of you have some next week too? Oh, that's bad timing. All right. Well, I'll be recording everything, and you're more than welcome to come in during win time if you want help with stuff, and come before or after school, whatever. Okay, I'm going to change question 2. I'm going to change question 2 because it's one of the shapes that I've been told you don't have to know. Are we confident enough I can start calling on people? No? Okay. All right, not a great sign, but that's all right. We'll keep pushing through. I mean, the only way you're going to start feeling confident is just doing more of them and getting used to them. Okay, find the volume of the solid whose base is a region bounded by that circle. Cross sections taken perpendicular to the x-axis. What are you guys doing? I was trying to go over the problem. Multiple people decided to start. Cross sections taken perpendicular to the x-axis are isosceles right triangles with the leg lying on the base of the circle. So that's the style question you're going to have on the AP test, which most definitely is a lot easier. So what I traditionally like to do is just draw a single cross section to get an idea of what I'm working with. So perpendicular to the x-axis, well, that means I'm going to just draw a single vertical line somewhere. It doesn't matter where you draw the 90-degree corner coming out of, because it would be the same either way. But that triangle is coming out of the paper towards you. So I need to learn what is the information for the top, what is the information for the bottom. Both of them are curves, so both of them are going to be constantly changing. Poirez, do you think you can help us out on either one of those two?
What was the question?
What's going to be what's the height of the top point? It changes constantly, but luckily we have an equation that tells us the height.
So I would take that x squared plus y squared equals 9 equation,
Okay?
and then I would kind of get it in terms of y. Like have
Perfect.
y on one
Perfect,
side.
perfect. I can't write the equation as we were given it because it's not a function. So our equations have to be functions for this to actually work. So x squared plus y squared equals 9. That's an implicit equation which doesn't work with what we're trying to do. We can't integrate an implicit equation. Integration only works with one variable for what you know for right now. It does move to more letters later, which is weird. So if I solve for y, that means my answers are going to be in x's, which is what I want because this is vertical. So I need to make this say y equals. Do a lot of you do this in your head yet?
It would just be 3 plus absolute value of x.
Nope.
Oh.
You have the right idea, but you can't do this absolute value. Close. You kind of made the same mistake as Tolkien. Cl- It's definitely not 3 minus x. That's the mistake everybody's making. Okay, I think most of you are doing the work right, but misinterpreting it. Like I'm assuming this is what you had and then you took square root.
Yeah.
You can't take square root of subtraction and addition. If that was multiplication, we could. So addition and subtraction you can't. So this is actually what you're going to leave it as. The plus and minus means that there's two separate equations. The top equation, the top half of the circle, is going to be positive 9 minus x squared. The bottom half is going to be the negative. So plus and minus means two separate things. I know you guys are just kind of used to seeing plus and minus all the time. We can write a circle as two separate functions because both of those equations on their own are functions, like they would pass the vertical line test, but together they don't. Okay. Josh? What numbers would I put on that integral?
-3.
Perfect. Now technically, this one is one where you can get right on accident sometimes. Like if you're not sure to pick top and bottom or left and right, well, it's a circle, so it's the same either way. But we want to do vertically, which is I think what you did anyway. So you start at x equals -3 to go to x equals +3. Okay, top information. Square root of 9 minus x squared minus the bottom information, which is minus square root 9 minus x squared. I don't necessarily want to call him a random person either. Does anybody know why? Like if I just started integrating this, it'd be wrong? Yeah.
Because if you plug in those numbers, you'll get 0.
Oh, I don't know. Might be. Did you already do that or what?
Well, I just know it's 3 squared, it's 3 squared negative 3 squared and 9. So they just go from 0.
Gotcha.
Oh, wait, never mind.
I don't think it shouldn't be 0. Well,
I'm not paying attention. I'm not like.
oh, if I added them together, it would be 0. But since they're being subtracted, it wouldn't.
You can get that area for this.
There we go. There we go.
Integrating the area.
It's really easy to just start writing down the info you know, but the whole goal is we have to integrate the area of the triangle. If it helps you, write that down first, and then kind of fill it in as you go. So we have to set it up as the area of the triangle. All we did is we figured out how long that line was that I just squiggled blue. All we did was figure out how long that line is. What would be the area of that triangle? Oh man.
1/2 base squared.
Okay, Foyer, is that what you're going to say too?
Yeah.
Yep. So the base that I just squiggled is going to be the exact same height or length as that line because you were told it's an isosceles right triangle. So base and height are the same. So I would square this and then divide by 2. Now I'm gonna put the 1/2 out front because I tried not to like full of stuff, but now this looks terrible and it should work a lot easier than you're expecting. This is partially why these are the questions you will get on the AP test because you can do them without a calculator. Square root plus square root would give you 2 of the square roots. So the minus minus gets the plus. So that means there's 2 of them. And then if I square this, I'm going to have 4 times 9 minus x squared. Now it's kind of up to you how you want to do the integration. You can bring that 4 out front if you want. You could multiply it out if you want. It's really up to you. I'm going to bring it out front because I like to make less things if I can. So I'm going to write this as 2 times the integral negative 3 to 3 of 9 minus x squared dx. So I'm going to integrate and get 9x minus 1/3 x cubed from negative 3 to 3. Now absolutely this is symmetric. So if you wanted to do 0 to 3 and then double the answer, you can. But I think a lot of you won't want to do that. A lot of you just like to directly go, which is fine. Oh, I don't have any more space. So what do I have? 27 minus 9. So 18. I flat out don't have any space, so I gotta. And I think this is going to be plus 18. So minus negative 18. Pretty sure it's 72, but I don't have any room to write, so I'm trying to do it in my head. That doesn't always work. What are we at? We get done at what, 4, 5 after? 4. Okay. Do you feel like you could try this one? Just try it. I mean, don't actually integrate. What I would like you to do, see if you can write the integral that would get the correct answer. See if you can write the integral that gets the correct answer. I would start by drawing a single cross section and then integrate the area formula. Try that. Did a lot of you have square root of x minus negative square root of x? Okay, honestly, that's good. That means you're kind of getting the idea. The semicircle is weirder because the semicircle doesn't go all the way from top to bottom. The semicircle only goes halfway. Because if you draw your semicircle, the radius of a semicircle is from the middle to the outside. So the formula for a semicircle is 1/2 pi r squared. And the radius would be that green line that I just drew. So if you did square root of x minus negative square root of x, that's really good. Because that means you're figuring out how to do top and bottom. I wanted to do a semicircle one because just to get you to realize that it's a little bit different. A radius isn't the same as a side length.
So, square root of x minus negative square root of x would be wrong, just put square root of x, or?
Correct. It'd be wrong.
Oh.
This one is correct. It would be okay if you did 0 minus square root of x as well.
It's correct because you're doing a semicircle as the area.
So if you wrote square root of x minus negative square root of x, you wrote the radius as the entire length.
Oh,
That's a diameter. A radius is half of the diameter. Yeah. The other shapes that we created, you needed the entire length for like a rectangle, square, or whatever, triangle. But on a semicircle, the measurement you need is from the middle to the outside.
So just a quick question.
So then for the,
He can go.
what?
He said go.
Oh, for the area for the semicircle, would you do 1/8 pi length squared or 1/4?
Half.
Half?
A regular circle is pi r squared.
Pi r squared, okay.
So a semicircle would be
Oh,
half
semicircle.
pi r squared.
Half pi r squared.
So hypothetically, if you did 1/4, and then you did top minus bottom, would that work though?
Yep.
Because it'd be like diameter.
Wait. No, actually it wouldn't. Because if you have 2 square root of x and you square that, you get 4 square root of x, or 4x. And then the 4 and the 1/4 would cancel each other out. And then it would be similar to having pi r squared instead of half pi r squared. So it would be twice as big.
So you have integral of 0 to 9 1/2 pi. The stuff in the parentheses, I'm just a little confused on how you got that.
The green line that I drew
Okay.
is the radius of the semicircle.
Yep.
The top of the green line has a height of square root of x.
Okay.
Bottom of the green line has a height of 0.
Okay.
So top minus bottom.
And you got square root of x by putting the equation of the graph into terms of y.
Oh, yeah. Yeah, because you were doing vertical cross sections,
Okay.
I need information in x's.
Okay.
So I took this equation and resolved it to plus and minus square root of x.
Okay. All right.
So top half was square root of x, bottom was negative square root of x.
Yep. Okay. That makes sense. Thank you.
Yeah,
Can you put the 1/2 pi on the outside of it?
definitely.
So if you did do square root of x minus negative square root of x, and you did the area from this 1/4,
Nope.
pi squared, that wouldn't work.
Nope.
But then you'd be,
Nope.
is it not proportional like that?
If you square this, you'd get 4x.
Oh, that's just.
And then the 1/4 that would be out front would cancel with the 4. And your answer would be twice as big as it should be. Because on this one, square root of x squared is just going to be x. And the 1/2 is still here.
So we only really need to do when it's like square root of x minus negative square root of x when we're using the full. We're using something that uses the full length.
Yeah, it totally depends on the shape that you're working with. If this was a square or a isosceles right triangle, then you would use the full side length.
Okay.
But area formula for a semicircle only uses that information.
Okay.
Yeah, it just depends on what shape you're working with. The formulas are going to be different every time. I mean, formula for area of a circle isn't, but the formulas you work with are. Oh, do you want me to go back to that?
I was just wondering, okay, so once you integrate.
Oh, do you want me to finish the actual integration?
Yeah.
Sure,
Please.
that's fine. So I would bring out the half pi like you said, just to kind of get that out of the way. And then square root of x squared is just x. So then I would have pi halves times 1/2 x squared from 0 to 9. So this would be 81 eighths. No, 81 halves minus 0. You could write it differently, but
Okay, thank you.
So my guess is we'll kind of set the next one up together, and that's probably going to be the end of the hour. Would you guys like me to do more of these together on Monday?
Yes.
Okay. Okay, find the volume of the solid whose base is the region bounded. How come we haven't done, oh, thank you. I was going to say, we haven't done any that were perpendicular sideways.
But these are gonna
Yeah, I guess I'm going to draw it first, though. Huh? X equals 0. Right there. Y equals 0. Okay, these are easy. I like these. This is a good start. And the next one is a regular line. I'm going to solve it for y just because I'm much better at drawing those. So this one would be y equals 3 minus 1/2 x. Oh, shoot. I'm going to need to make my graph bigger, I guess. So 3 minus 1/2 x, down 1 over 2, down 1 over 2, would cross at 6. So it is going to be important to know where it crosses on this one because that's going to tell you where you begin integration and where you end integration. Sometimes it won't matter where they intersect. Sometimes it will. Okay. So my base shape is this triangle that was made by the intersection of those three lines. If the cross section's taken perpendicular to the y-axis, okay, let's change it from equilateral triangles. You guys seem to have the hardest time with the semicircle. Should I do another one of those? Okay, so if I draw my single cross-section area, it is going to be a circle that goes that diameter. And because it's a semicircle, I know I'm going to need the radius. Should I pause for a little bit? I see a lot of you kind of staring at that. I don't know if you, I'm thinking a lot of you are just trying to like picture what we're working with or something. Do you guys want me to answer questions on anything I drew? Okay. So I need to integrate the area of the semicircle. And then it's going to be dy because I'm horizontal. So I guess I'll write my numbers first. Horizontally, this would be the first semicircle I would draw at y equals 0. The last semicircle I would draw would be at y equals 3. So this one's going from 0 to 3. If it was vertical, it'd be 0 to 6. Okay, then I'm going to write 1/2 pi r squared. My radius is the weird thing. The right-hand side of my radius well, it follows this straight line. This straight line, if I solve it for x, would be 6 minus 2y. How about that point? And honestly, there's different ways we can set this up. I drew the radius from the middle to the right. You could also draw the radius from the left to the middle. Doesn't matter. Okay, how come I know that that information is going to be half of 6 minus 2y? I mean, like, I was assuming you guys were going to think of it geometrically. Like, no matter where I draw that semicircle, the center is in the middle, right? And so 6 minus 2y stands for how far over the point is. Not how high, but how far over. So the point in the middle will always be halfway.
Oh,
So it's half of that answer. And you would get the exact same info if we... Okay? So, actually, you know what? I need to move that over. Hi. Oh. So I'm going to say right-hand side minus left-hand side. You can simplify that however you want. I'm pretty sure some people would just multiply out the negative half, take away parentheses, whatever. Doesn't matter. I think this might be a good opportunity for you guys to see if you can type this in correctly on the calculator. Because we haven't done calculator on a single one of these so far. Actual calculator is a good thing, yep.
well, no, because I obtained a TI-83 plus from God knows where, and I just used that. I just kind of reach into my backpack and pull out whichever one I find.
Okay. So I am going to be sort of sneaky on my answer, and I'm going to leave off the pi so that I can write the exact answer with a pi. But if this was a calculator question in the AP test, then they're not looking for that. Okay, so 0 to 3. 1/2. I'm going to write it exactly how I have it, because otherwise I feel like I'm going to screw it up. 1/2 times green parentheses times black parentheses, 6 minus 2, I don't have a y, but minus and most definitely, if you are doing this without calculator, you would simplify a lot of this beforehand. I'm just not, because I don't need to.
Oh, I did that wrong.
You did that wrong.
I got 7.
Like 7 even?
Yeah, I
I
didn't.
got 7, but I didn't square root, like, or square.
I didn't square it. Yeah.
Not right.
You did square it on the pi halves as well? Okay. To see what I typed in?
Yeah.
You bet.